Great. So it's been great interacting with many of you. It's been, I've got a lot of great feedback, a lot of great kudos for the things that went on yesterday, and obviously a lot of great comments around Altium Designer 18. So as Snoop Dogg once said, I really feel the love, per schism. Don't know what the per schism part is, but it sounds cool. So as Ted said, we're going to start with and introduce Altium Designer Nexus. So yesterday you saw Altium Designer 18. And you saw the new robust design environment. Altium Designer 18 is really focused on making high performance simple, enabling it to make it easy, powerful, and modern. So the data sharing inside of Altium Designer 18 is a bit limited. If you're working with other engineers, the process of collaboration is a bit ad hoc. Nexus focuses on this part of the design. It's when groups of engineers need to be able to work together in a much more collaborative fashion in a seamless process. So with that, we're going to go ahead and let someone talk to us about what it means to work together.
Most of my professional career has been as a contract engineer. I've been doing it for about 20 years. My primary role now is developing high-end, designing high-end circuit boards, multi-processor designs in the aerospace industry. It is rare that you build one board that lives on its own. Most everything we design nowadays lives in a family of products, a family of boards. To move from being an individual into working in a team, my granddaughter said it's sort of like coloring in the lines. As an individual, you can be creative, you can do the things that you want in the way that you want. As you start working with a team, you have to learn to color within the lines. There needs to be a structure that everybody agrees to so that you can work together. In the aerospace industry, for instance, you'll have groups that focus on RF designs, groups that focus on the digital designs, groups that work on power supplies. Then you have assembly level groups that work on getting one board to talk to another board, either through backplanes or through harnessing. And so in working in a team environment, it's important to communicate well. And that's in my experience where, oddly enough, more of the difficulty comes in. The actual design process of putting the board together or designing the board out, getting the copper traces where you want them, is the easier aspect. We set up design rules. The rules set up the guidelines of how we do it. Trace widths, clearances from vias to tracks, net classes to other net classes. Being able to structure a design based upon design principles is important. That is where we focus a lot of effort in setting up the guidelines of how a board will be designed so that multiple designers can get in there and do the design. I may only be interested in connector A, and you may be interested in connector B, but the person who has to make the cables is interested in connector A and B. And so being able to share that information on a multi-PCB design, yet let me be in control of A and you be in control of B, and work with each other, but be able to hand that off to the individual who has to pull it all together is vital. Now we introduce the engineering aspect into the design while still allowing the freedom, the graphical freedom of the PCB designer to get the job done.
Okay, so my apologies. It looks like the audio was a little bit off. It was a bit like watching a kung fu movie. So you heard Tim talk a lot about the challenges that are to working together. And obviously when you start collaborating, it becomes extremely difficult. And we'll talk more about that in a minute. So I'm sure many of you have heard or read the Athena name. And so to avoid any confusion, Athena was a name that we used internally to describe the product that we were developing. Okay? As we started working with customers and the product began to mature, it became evident that the name didn't properly portray the intention of the product itself. So the new name is Altium Nexus. And if you look at the definition of Nexus, it personifies what this product is. It's a means of connection to tie or link. It's a connected series or group, the core or center as of a matter or situation. And I think you'll see a lot of this as we start progressing forward. So over the years, PCB design tools have evolved significantly. And so when you start creating something, it's become much easier based off of all of the different simulation and automation that's available to you today. And as engineers, even if that functionality is missing in the tool, we're pretty creative people, right? We'll find a workaround or we'll create a workaround. So why is it so many companies still fail to deliver products on time? And so if you consider the following statistics where 33% of new products are late getting to market, I mean, that's a significant statistic, especially when you talk about all of the different competitor players in the field today and who you're looking or competing against, especially all of these startups. 28% of these are late due to insufficient collaboration, which lends itself to the working together aspect, because it's very rare that a product you deliver is solely controlled by you from concept all the way to manufacturing. And then up to 50% of revenue potentially lost when late to market. And that's pretty substantial overall. And I've actually experienced that firsthand where I was working with a company and they were actually working on a product where they missed the product window by 2 months. And in that particular industry, 60% of the revenue for that product is actually realized in the first 4 weeks of introduction. And because they were so late against their competitors, they killed the entire product line. Okay? So what this lends itself to is probably each of you individually are great at what you're doing, and that is getting your portion of the design done. But the reality is when you start throwing more people into the mix, the process becomes much more complex and the communication breaks down. And for those of you, I think all of us were in here during Max's presentation, and you can see the arduous time that he spends in documenting his schematic. For why? And that's to be able to communicate that design intent to people who are downstream, open those lines of communication. So working together is extremely hard, and the intention of Nexus is to really make it easier. So there are a lot of data service providers out there who have either moved to the cloud or in the process of moving to the cloud, and Nexus is no exception. And so all of you who work for companies that have ITAR and data sensitivity, don't worry. There'll still be an on-premise version available to you, but there are distinct advantages to the cloud itself. And I think some of you are probably using cloud services in some form or another. It's much easier to deploy. There's no setup, install, or configuration as part of that. It's much simpler to maintain overall based off of it being a cloud instance. There's no additional hardware requirements for you. It adapts to your workflow. So there's a lot of systems that get introduced where you actually have to change your design process to match the system. Nexus allows you to configure the system exactly how it is that you work. It has completely flexible administration. You're going to see this very graphical-based user interface that if there are things that change during your design process, you don't have to go in and write some type of custom script in order to adapt what's changed. You can very easily do that in the Nexus admin environment. It's got incredibly low IT overhead. The updates itself, because it's cloud-based, are completely transparent, as well as since it's cloud, it's very easy to spawn an additional instance. So if you want to have a production instance and a test instance and replicate those, you can do that seamlessly. And the performance overall is very high in regards to it being a local server. So I know John presented yesterday, and WattStopper is actually using a cloud-based implementation of the Vault, and he'll tell you based off of all of his geographic locations that are accessing it, the performance is actually quite good. So when we talk about working together, I think all of us will look inward and be a bit selfish and probably look within the immediate space of our design group. And usually that's within the design authoring space, okay? And that's usually where we're focused. But outwardly, if you look at generating that product, there are a lot of other people that have to contribute, many of those people who are not designers. And what we end up doing is generating additional documentation for them to be able to view, For those of you who were with Judy Ellis yesterday, she really emphasizes the need to generate fabrication PDF documents so it's easy for her to be able to view that information on the road. That's great, but there's also limitations in the context of that, because as you do things like make comments, you now have to capture those external to the documentation that reflects the version that you're working against, okay? The other thing you'll notice is that if you look at the definition of team, I think most of us will think of team as the people who are in the walls of your organization. And that's a pretty traditional view of team. Most startups that we've worked with, their definition of team includes all of the external contractors that they're dealing with. Because these companies are small and they have to move quickly, they can't spend the time in order to train the expertise in-house, so they'll just go seek it out. But they, once again, need to be able to work with them interactively as part of that whole concept as a team. So Nexus allows you to set up all of these different roles, manage the permission set against these roles, the access to the data they have available to them, and if in fact they are external, it's completely secure. So Ted showed an interesting slide yesterday, which I'm sure a lot of you started pondering, and I actually had a number of people come up to me and start asking me questions about it. And that was the slide where you saw Altium Vault, Altium Designer, and Siva technology converging into this stream called Nexus. And so the question I got is, well, what's happening to Altium Vault? Where is it going? If I'm on Altium Designer 17, I'm on Altium Vault, where do I go? Where you go is you go to Nexus. So Altium Nexus, the authoring environment, is exactly the same as Altium Designer 18. There's no difference. Okay? There's no difference in functionality. There's not a high or low version in regards to the creation of the design content. The Vault content and the Vault functionality that you're used to in Nexus is exactly the same. So there is no loss of functionality. The only thing that's going to change is the brand name that you happen to be using, as well as there's some additional collaboration features that you'll see shortly. There's no uplift in cost, so the transition is seamless. You just say I have Altium Designer 17 and Vault, I just go to Nexus. It's that simple. So when we talk about Nexus and we talk about Vault users transitioning to Nexus, there's also a next level of Nexus above Vault, which introduces a whole host of additional functionality that has to do with different areas of design collaboration. And once again, those collaboration pieces aren't necessarily just for the designer themselves. It's also for external collaborators, which is why there is something called Nexus Collaborator. It is a per user or per named user license. And you can see that the collaboration has a $495 price tag a year for per named user. It's actually quite cheap when you actually will see the functionality that you can realize through this. So just to give you some insight so you can take a look at sort of the breakdown of functionality, you have Nexus compatibility mode, which is anyone who's on 17 and Vault will immediately go to that. The functionality is exactly the same, as well as they gain some collaboration capabilities within the authoring environment. You have Nexus PCB Designer, which is the entire Nexus suite. And that really enables a lot of different functionality in regards to being able to do not only the collaboration within the design environment, but also process collaboration, like things like design review, new part request, new project creation, and those types of things. And then you have Nexus Collaborator, which is really designed for external contributors, people who don't use the authoring environment, people who don't really care to use the authoring environment. I know today we offer a free viewer for Altium Designer, and when I visit customers and I say, hey, do you use the viewer? The majority of them, if they're designers, say, oh yeah, it's a great. But if you talk to the managers and the purchasers and other, they say, I'm not going to use that. I need to know how to use Altium Designer. So even though it's free, it's pretty useless to them overall. So what we're going to do is we're going to walk through a demonstration that goes through a number of different collaboration use case scenarios. There are 3 different workflows that we're going to cover. There's design collaboration, which is the authoring piece and multiple designers collaborating to achieve the same goal. There is process collaboration, and the particular workflow that we're going to go through is a design review process and what that looks like and the number of collaborators that can effectively be involved in that, designers and non-designers. And then we're going to take a look at how is it that you configure and set all of that up, because a lot of the times what ends up happening is people see that, they say it's wonderful, but the overhead to achieve something like that is pretty significant. And we're going to show you that that's not the case at all. It's incredibly easy. So the initial, I'm going to set the stage. The initial situation is we have 4 designers, a schematic engineer, a PCB designer, a system engineer, and a mechanical designer, and they're working on the next generation mini PC design. So we've got Mike Doyen, who's the schematic designer, and during a design review, it was realized that the mini PCI connector being used in the design is possibly facing end of life. Furthermore, the idea to have the connector facing outward such that cards could be easily swapped in and out was considered a bad one, and we want to rotate the connector 180 degrees facing inward. So Mike can go ahead and look at possible solutions or alternates for the part that's going to face end of life. Once he's found one, he has the ability to compare the schematic symbols in the PCB footprints. In this example, they're exactly the same. It's because it's the same Tyco connector. The only difference is the height is different, which means it's a different part number. Once Mike finds a possible alternate, he can then go ahead and search the part information and then qualify that it's actually available for volume production. In this case, you can see the life cycle. He then has the ability to place that part directly out of the Explorer view and place it into the schematic. And once again, because it's the same part from the same manufacturer, there's no pinout change, and so there's not a lot of rework. He has the ability to go ahead and open up the Nexus collaboration panel, and then he can make comments in regards to the change he made. So he's going to say, hey, I changed the connector, and I changed it with this part number, and then everyone who's involved in this design will be immediately notified of that change. The routing of that is handled by the Nexus server itself. So Chris, who's the PCB designer, he sees that Mike's change has come through. Okay? He's immediately notified. He can run the ECO engine directly from the collaboration interface, which instructs him to pull in the changes from the schematic. He goes ahead and he'll run the ECO process and he'll update the design. The footprint will get updated, and then as you remember, we wanted to change the orientation of the connector so it was facing inward. Because of the orientation change, it also has impact to other designers. Perfect example of that would be the mechanical designer. It now affects the mechanical assembly. If they had a slot in the side of the enclosure so you could swap cards in and out, the mechanical designer has to make that change as well as realize the part change in the assembly. So just like Mike did, Chris is going to go ahead and post the changes to the Nexus collaboration server. So Ben Jordan, who's a busy guy, not only is he demoing Altium Designer 18, but he's also the mechanical engineer. And so inside of PTC Creo, he'll get a collaboration panel, and he's also notified of the change. You'll actually see Nexus allows you to accept, review, and refute changes. If you refute a change, it'll just keep a history of that change. In this case, Ben's going to go ahead and say, hey, Chris knows what he's doing. I'm going to go ahead and accept all of those things. And it's going to update the connector rotation. You'll also notice that the board outline has these flanges, and to optimize on manufacturing, he's going to remove those flanges and just make it flat. And then he's going to post the board outline changes back to the Nexus server. So Chris, in his environment, is working, and then he realizes that the mechanical guy has made a change to the board outline. He's going to go ahead and pull the mechanical changes into the Nexus environment, and he can see what's actually changed, and he can review it, and he can graphically see what's going to change. He's going to go ahead and click to accept that change and propagate it into the PCB space. And then you'll see the board outline automatically updates based off of the changes that Ben did inside of Creo. It's magic. So we're going to take a step back for a moment, because as Chris had pushed the initial connector change to Ben, he was actually doing some routing at the exact same time. And as he was routing a differential pair, he realized that there was crossovers, so he's going to go ahead and do a pin swap so he can complete the routing. So these things don't necessarily need to happen in linear fashion. So Chris is going to go ahead and post the swap changes to the Nexus server. So now we've got Alexi, who's the system design guy, and he's managing the entire design. And he's inside of the multi-board schematic. And so inevitably, all of the changes you've seen happen up until now has happened in only one PCB project, which is the mini PC design. But what ends up happening is engineers make changes without the consideration for the greater system. It's up for the system designer to resolve all of those differences. So just like everyone else, Alexi's notified from Chris that he swapped some pins on the main motherboard. And so Alexi said, well, that's not good. What changes happened? What's the impact? And so he has the ability to select the module and import the changes from the child project. Because once again, all of those modules represent different PCB projects. He runs the exact same ECO process, and then he goes and opens up the connection manager, and he has the filter set to just show me conflicting connections. And so he sees that there are two connections conflicting based off of the pin swaps that Chris did in the mini PC motherboard. And when he goes ahead and he selects those, he can see it affects the daughter card that the motherboard is connected to. So Alexi's going to say, well, that's not good. I need to update the daughter card. I'm going to go ahead and confirm and propagate those changes into the system design itself. So now that the system design is updated, he still needs to push the changes to the actual daughter card that it's connected to. So he's going to push the swap changes to the Wi-Fi card, and then it's going to go ahead and update that design. So finally, as you guys saw yesterday, this is the entire system assembly view for the multi-board configuration. Because of the connector rotation change, Alexi's going to start assembling the cards to look at the final system assembly, and he realizes, well, we rotated the connector, the card's facing inward, but we didn't take in consideration that SMA connector that it interferes with. So rather than having to send Chris a notification, inside of this multi-board assembly view, Alexi has the ability to push into that motherboard and do simple changes like component location. So he can go ahead and update that component location, resolve the conflict, and then he might want to be playing around with some other placement options. And then he can go ahead and push those changes back to PCB. So this is the final system assembly in all its glory. And even though it was a very basic scenario, it's quite difficult, you can see, if you thought about in your heads what it would take for you to do that today. And finally, a lot of times what happens is when companies introduce new products, they'll say, hey, you got to get to the latest and greatest. Databases are not compatible. That's not true. We truly feel that there will be companies that operate in environments that are using both Altium Designer and Nexus, so the databases are completely compatible between the two software. So you saw an example of design collaboration, but there's more collaboration than just the authoring itself. There's a lot of other people, once again, stakeholders who are involved as part of getting the design from process all the way to manufacturing. And so let's take a look at what it takes to do something like a design review when you have external people contributing to the design itself. So we've got Mike again, and Mike is the project manager for this particular design. And so Mike wants to, they've made all of these design changes, they've updated connectivity, and they've updated the connector, and now Mike wants to initialize a design review. But before he does that, he realizes that there's an area of the Ethernet circuitry that he's concerned with. There happens to be a particular linear tech voltage regulation module that he doesn't have a lot of experience with, and so he wants other people to really take a look and say, hey, did I correctly use this part? So he can go ahead and he can add a comment area inside of the design itself, and then he can attach a comment, which once again, the comments and the history are managed by the Nexus server. And then he can go ahead and post that, and you can see it very clearly indicates the circuit that Mike's looking at, and it posts the comment right next to the circuit, and it posts the comments to the Nexus server itself. At this point, he's going to select the project, go to project activities, and he's going to initiate the design review. It's going to go ahead and open up a design review form, and this form is completely configurable. So whatever you wanted to see in here, you could create, which we'll see later. We've just created a very simple form. So Mike's going to go in there and define a request title to initiate the design review. In this case, he's just going to say schematic milestone review. He's going to go ahead, and you can see that the project is automatically attached to the review because it knows where the review was initiated from. He's going to add a description in there to say not only take a look at the schematic, but it'd be great if you actually validate the PCB placement as part of this review as well. And then the part list check, because it's optional, he's going to say, I'm not going to worry about that right now. Let me set that to no. And then he can go ahead and assign who those reviewers are. Those reviewers are the roles that are defined on the Nexus server by the Nexus administrator. And so he's going to find John Smith, who's an electrical engineer on his team, and Chris Carlson, who's the PCB designer. And then he has the ability to attach files to it. In this particular case, he's going to attach the actual design requirements themselves so people can refer back to them as part of the design review. Chris and John are going to get notifications, and Chris happens to be on the road. So he doesn't have his machine with him. He's going to log into the Nexus server because he doesn't have Nexus resident on his machine. He gets an email notification. He goes to his task list, and he sees there is a due review task assigned to him. If you look at the form for the review task, it's different than Mike's because this is the actual checklist to physically do the review itself. And once again, this is completely configurable. So he can look at the different things that is required by him to actually do the review, like check the decoupling caps, look at pull up and pull down resistors, check at non-used pins. But because Chris doesn't have Nexus installed on this machine, he's going to open up the collaboration interface, which opens up the design in a browser. Okay? It's very simple to use. You can see it offers the exact same design content. You can see all of the schematic sheets on the left hand, or excuse me, on your case, yeah, the left-hand side of the user interface. Okay? So before he initiates the design review, he's going to view the comments. He double-clicks on the comments that Mike has listed, and Chris can clearly see inside of the browser that there is the comments that Mike, and you can see Mike's shiny face right next to his comments. He was the last one that posted anything against that thread. So Chris has experience with this particular linear tech device. He observes it, reviews it, and says, hey, things look okay to me. I'm not sure what Mike's worried about. He did a great job. He's going to go ahead and respond to the comment. Then he's going to post those changes. And once again, that history is being managed by the Nexus server. So once he's responded, at this point, he's going to go back and he's going to start the review process. And so Chris knows the first thing he wants to start looking at is the coupling capacitors. And because the coupling capacitors are most commonly associated with power pins, he's going to open up a particular design sheet that he's interested in, which is the PLL schematic. And he's going to set the visibility just to look at the schematic itself. And then he's going to do a search just on VDD pins. And it'll give him a list of all of the VDD pins in that schematic. You can see using this is not a mystery. It's no different than using a PDF. It's very simple in nature. And when he clicks on it, it's going to cross-probe directly into schematic and go to where he's looking. Okay? He can look at the capacitance values and say, yep, looks good to me. But as the PCB designer, his main concern is how well were those things placed to the power pins themselves. And so he can open up the secondary instance that has the PCB design and be able to cross-probe between the schematic and the PCB. Keep in mind, this is a browser. This isn't the design environment. This is the collaboration environment inside of Nexus, and it's utilizing browser technology. Okay? He can set it so it does a cumulative selection. In this case, it's selected the actual chip as well as the corresponding decoupling capacitors. And he can say, hey, yeah, placement looks quite good to me on this one. Let's move to the next one. Okay? Once again, it navigates to the schematic itself. He can look at the values of the capacitance values. He can select them. It'll cross-probe over. And then he can validate that they were placed appropriately closest to the power pins that he's interested in. So because Chris doesn't have the environment, you can see it doesn't limit him. The interface is extremely easy to use. It's intuitive. It's no different than utilizing a PDF. But the advantage is you're collaborating on the exact same data source that originated from the designers themselves. So Chris is going to go through. He's going to validate all of those checks. And then he's going to go back to the review form in the browser and say, yep, looked at all the decoupling capacitor values, and that looks good. I'm going to go ahead and accept those. And then he's going to move down the list, and he's going to say, oh, validate unused pins. I'm the PCB guy. I don't really want to do that. And I'm going to leave that up to John, who's the other electrical engineer, and he's going to denote that he didn't check them. And then he'll go to the next thing, which is validating the pull-up and pull-down resistors. Okay? So once again, he'll go back to the schematic view. And in this particular case, he's interested in the resistors that are being used with the communication protocol in the design. In this case, I2C. And because Chris has a lot of experience using I2C, he knows that the common pins that he's interested in start with SCL. And so he's going to search on pin SCL, but he's going to change the scope of the search to search across the entire design, not just one schematic sheet like he did before. He'll get a list of those pins, and once again, selecting on them will navigate to the appropriate schematic sheet. He can view the resistance values, and in this case, he's a bit puzzled and says, hey, those values seem a little bit large to me. Not quite sure if Mike checked the data sheet, but seems like he might have not been really paying attention that day based on my experience. So just like Mike did, Chris can go ahead and add a comment inside of the collaboration browser interface, selects the resistors and say, guess what? Not quite sure. These values are good. They seem a bit large to me. I want you to go back and validate these against the data sheet. And he can post those comments. And once again, they're handled by the Nexus server. So now he's going to go to the next one. And he can look at that, once again, check the resistance values and say, yep, things look good. And you can see this recursive nature. But once again, this is inside of a web browser interface. This isn't the native design environment. But you're using the exact same data set that the designers used to create it. So he'll go back to his do review. And he'll say, yep, checked all of those resistance values. Things look good. But there was that one issue that I was concerned with. So I'm going to say it's not accepted. And I'm going to say because of the area of the value of those particular resistors that I thought were maybe too large, please take a look at the comments that I made inside of the design. He'll go move to the next thing, and let's just say he went through and he validated all the inputs and outputs, and he'll change that to accepted. And then he'll scroll down and he'll give his reviewer vote. And in this case, because of the issues of the resistance values that he questioned, he says there's minor issues. And then he'll denote his notes. And then he'll submit his review. So a lot of the customers we spoke to in the past, when they go through this review process, is very ad hoc, and they're using external systems like Word documents and notes and things like that. So John was the second reviewer, and John happens to have access to the Nexus design environment, so he doesn't need to use the browser interface. You'll see on the right-hand side, there's a task list panel, just like Chris saw in the context of the browser. Okay? He can see, based off of the email he received, there's a do review task for him to take a look at. But just like Chris, before he starts the review, he's going to look at the comments panel. And he can see two different threads in the comments. There's one from Mike and there's one from Chris. So he's going to go ahead and take a look at the first one that originated from Mike, and you can see Chris's comment saying, no, it looks good to me. So John clicks it, zooms into the area. He also has experience with this particular linear tech device, and he says, yeah, I know what Mike's talking about. I agree with Chris. Things look fine. Properly used. Everything seems to be in order. He's going to go ahead and respond to that and post his comments. And then he's going to go to Chris's comments in regards to those resistance values. He'll select it. It'll navigate to it. He can review it. And based on his experience, he's also saying, hey, I agree with Chris. Seem a bit large. Mike, it'd be great if you could validate against the data sheet itself. And then he'll go through and he'll post his comments. Now that the comments are done, he's going to go back to the task list. He'll open up the do review task, and you can see it's the exact same form inside of the design environment that Chris saw in the browser itself. Okay? So there's this consistency in regards to the process. He also has the ability to click to the diagram tab, and he can see the entire workflow and what the different transition states are. In this particular case, it's in the do review state, and John's the bottleneck right now because everyone else is done. It's only his name that exists in that state. And then he can see where it would transition next. And so he's going to go back through and do his job and do the review. So we'll just say, hey, a couple in caps, he checked all of those. They were accepted. He went through and he validated all of the unused pins. He's going to say those were accepted. He's going to get down to the pull-down resistors, and he has the exact same concerns that Chris has. So he's going to say that it's not accepted. and for the exact same reasons that Chris did, okay? And then he'll go down to the next one, and he'll say he's going to validate the inputs and outputs, and he'll choose that to be accepted. And then he'll give his reviewer vote. So regardless of how many collaborators you have, you can see the consistency in regards to the information that's being checked. He's defined that there's minor issues. He's going to include his reviewer notes in regards to those resistance values, and then he'll go ahead and submit his requests. So now the two people that Mike assigned to do the review have both completed their review process. Okay? Now that they've completed the review, based on how the workflow was defined, all of that goes back to Mike. So Mike's in his design environment. He gets a notification, and it basically says, there's a task. You need to analyze the feedback. Okay? So it's transitioned from the initiation to the different reviewers to the review state, now to analyze the reviewer feedback. Mike can also look at where things are in the workflow and how it transitioned. So he can see where it's gone from, the do review, it's gone through that gate, and it's now an analyze the review feedback, and he is the only one, because he initiated it based off of the way we have the rule set up, that is the bottleneck right now in regards to analyzing that information. So just like before, Mike's going to take a look at the comments first. He sees that both Chris and John responded to his concerns in regards to that linear tech voltage regulation module and says, things are great. Mike say, okay, will do, thanks so much, and he can resolve that comment. So it's gone, but the history of that comment is still maintained, so you can always refer back to it. So then he's going to look at the thread that Chris initiated, and you can see that double clicks on it, zooms into the area, and you can see John's comments as well. But Mike's a good engineer. He did his job. He validated those resistance values against the data sheet, and he said, no, I did, guys. Things are good. And then he can go ahead and resolve those comments. Okay? So he'll go back to his task list. He'll go back to his task of analyzing the reviewer feedback. And this time it opens up a different form, and this is the summary form. Okay? All of the information in this form is in a read-only state because this is the feedback that all of the reviewers provided. Mike can see who's done the review, what comments they made with the review, what values were associated with each one of those different review criterias, and he gets a complete summary of everything that was done in the review regardless of how many contributors there were. So Mike can go through, look at the various comments. He sees the only comments that are really relevant are the things that he already resolved in the comments field, validating that he did check those resistance values against the data sheet. And if, in fact, there was rework required, he could go in and assign who the engineers are to do that rework. But in this case, he's going to say, nope, the only issue that they had, I've resolved, and the review is complete. Analyzing the feedback is complete. And then he's going to go ahead and submit the form. Okay. So now you've got Carol, who's the engineering manager. Carol, of course, doesn't have access to the Nexus authoring environment, so she's going to go ahead and log into the Nexus server through the browser. Carol got an email that, hey, review's been done, and now it's in the hands of her in regards to her task as giving it the final manager sign-off as the engineering manager. She's going to click on her task list, and she'll see manager check. Wow, the email wasn't lying. And then when she clicks on the manager check, her form looks completely different. She can see who the reviewers are. She can see when the completion date was scheduled. She can see the checklist associated with the review and the summary of everything that was done as part of the review and who did it. She can look at the workflow diagram and see how it's transitioned through the workflow and what state it currently exists in. Right now, Carol's the bottleneck. She's the only manager that needs to qualify the final check before the review is completed. She can also go to the projects and look at the mini PC design project and say, I'm curious as the manager, what are the other workflows that are currently active as part of this design? And so she can look at all of the activities that are currently in progress. And in this particular case, there's only two. There's the design review, which is currently in her hands. She can see she's assigned to it. And then there's the publish to PLM, which is currently in Mike's hand. And most likely, Mike can't publish to PLM because Carol hasn't approved yet. So Carol's the gate. So Carol, you're curious to know what that publish to PLM process looks like. And then she's going to go back to her task list. And she'll review the summary of all of the information. In this case, she'll just go ahead and click submit and say, yep, because everyone else is good, I've done my quick review, I'm good. And she'll accept it, and it'll go into a completed state. So inevitably what ends up happening is as you create these workflows, problems arise. And in this particular case, Carol gets an email from Michael, who's the Nexus admin, and say, hey, the manufacturing guy, Tom, just let me know that this particular part that you're using in this design, not sure if you're aware, but there's a 3 to 4 week lead time on the part. So Carol says, okay, well, that's okay. We'll still meet our window, but how did that happen? Why was that ever allowed? How come it wasn't noted before? So she goes ahead and logs into the Nexus server. She looks at the projects. She goes to the activities, and then she can look at all closed activities, all active as well as closed activities that have been completed or rejected or what have you. So she can see that there was a design review done. She can see as part of the design review, there's supposed to be a part list analysis. So she goes to the data, and she said, well, it's in the design review process workflow. What happened? Well, guess what? That part list thing is optional. Well, that's not good. Here's the reason why that we have the issue in regards to the lead time on the part that we weren't originally aware of. And so Carol's going to send email back to Michael, who's the Nexus admin, and say, listen, we're okay. Even the lead time, we'll still make the project window, but it's concerning that this was never addressed to begin with. So to avoid this problem in the future, I want you to go ahead and modify the workflow, the design review workflow, so the part list check is absolutely mandatory. It's no longer an optional thing. It has to be done in parallel with the review process. She's going to send that off to Michael to go ahead and update it. So Michael, the Nexus admin, who looks a bit surprised that he's the Nexus admin, is going to go ahead and log into the Nexus server. And so you can see because Mike is the admin, he has a whole slew of capabilities that no one else had available to him. He can go into the processes, and under project activities, he can actually see all of the different processes that are available. In this case, he's going to go ahead and look at and edit the design review. So he identifies what Carol told him in regards to the part list analysis check. He sees that it's optional, and he says, great, easy enough. I'll just click on that and remove the condition. It's no longer conditional. Has to happen. It always happens. Okay? And then he's going to go ahead and save the workflow. So you can see how easy it is. There's not a lot of overhead here in order to make changes like this to adjust for things that are occurring as part of your daily workflow. Okay? He's also going to go into the initiation form for the design review, and he's going to remove the part list optional field from the form, and he's going to remove the part list label that describes what that field does. And then he's going to go ahead and do a test on a design and initiate a design review to ensure what he's done actually works. So based off of this test, Tom, the manufacturing engineer, gets notified in email that he's got a task. And so Tom opens up the Nexus interface, and he sees there's a part list analysis check that he has to do. So he can see the part list check form. He can see the test project that's assigned to it. He can see the associated description with the task. And then there's also an attachment. In this particular case, it's the bill of materials. And you can go ahead and open that bill of materials, download it. And then he can also look at the diagram and confirm that the workflow is working appropriately. Part list check is going in parallel with do review that has 2 assigners. Okay? So he's going to change the one state inside of the part list updated needed, saying, hey, looked at the part list, looks good. Going to go ahead and say, nope. No updated needed to the part list. And then there's a section for him to be able to add attachments as well. So he's going to attach a bill of materials that he's added comments into to make purchasing aware of different situations with different parts, things to be mindful of. And now he's going to go ahead and he's going to change the lead time for the longest lead time on the part, which happens to be the one that's causing all the problems, which is 3 weeks. And then he's going to go ahead and submit his changes. So it sounds trivial, but I would beg to ask how difficult it would be for all of you, if you're working in a team environment, to do that. And so the last piece I want to cover, we talked about design collaboration, we talked about process collaboration as it has to do with, as it relates to design review. But what does it take to set all of that up? There's a lot of systems out there that are incredibly heavy. It takes a tremendous amount of work in order to deploy. I've been in situations where I've worked at organizations and we've deployed enterprise systems, and it can be a tremendous amount of work. So we're going to show you how easy that is. So Michael, who's the Nexus administrator, logs into Nexus. He's going to go to his administrative functions, okay? And as part of the processes, Nexus has a lot of the out-of-the-box functionality. You'll see that there's a series of tabs available to you at the very top. One is the browser tab, and it shows you all of the active processes that are currently going on as part of your organization. So at any time, the Nexus administrator can see everything that's moving, all of the moving pieces, and he can click on each one of those and see each of the states of where those processes exist. In this particular case, he's really picked a really simple scenario in regards to a design review, and they're a bit more complex one. But these are all of the out-of-the-box things that you can use, and you can see these are currently active. You can look at the data information associated with each one of those processes. He looked at a part list request, and you can see the name of the part, you can see the data sheet attached, you can see the part number. And so as the administrator, all of that data is available to him as well. Okay? You also have the ability not to just look at the active things that are going on, but there are times that you need to trace back the audit trail of what occurred before. And so he can look at all of the closed activities as well and see the states of close that they're in. In this particular case, there was a part request that was rejected, and he can go to the data and he can look at the situation of scenario, why that might have been rejected. Maybe it was already a duplicate part. Maybe it existed already, and the designer who requested it to begin with didn't even know it. So he's going to go ahead and he's going to select, you'll see that there's a series of tabs at the top for different process types. One is part request. Inside of part request, you'll see 3 different part requests that are available. Those come default as part of Nexus. You don't have to create them. So if you wanted to start using those right out of the box, you could go ahead and do that without any configuration, or you could go in and modify each one of those. Each one has a different level of complexity. The top one is probably the most complex, where you have multiple contributors involved in a part request. Might be a separate person generating a symbol, a separate person generating a footprint, someone actually doing the part validation, so forth. The bottom one is the most simple case, where you have someone who initiates the part request. It goes to them, and they say there's not enough info, and then it just goes back to the initial assigner. And then once they assign more information, it goes back to the person responsible. So in this case, not only is Michael the system admin, it looks like he's also the librarian. He's got a tough gig. So you'll also notice that on the right-hand side, we show you the status of all of those processes. None of them are being used except this really simple part request. You can see it's already been started, it's initiated, it's been used 3 times already, it's currently active, and then you have the ability to edit. There's no remove feature, because obviously you don't want to remove a process that's active. If you go to the Project Activities tab, you'll also see a series of default project activities that are part of Nexus. Once again, you can start using them right out of the box. There is the most simplest review process, which only has 2 states. And then there are some that are much more complex, which have a number of different states depending upon approvals and rework. Okay, and this one is a much more linear waterfall flow. So you can see you can create workflows to be in a linear sense or a parallel sense. It makes no difference. Okay? You can conform it to exactly the way you work, not conforming the way you work to how the system works itself. And then there are other ones like publish to PLM, which is a common one. After you finish the design, everything's been approved. There's a lot of times you have to take that design content and publish it into PLM. So you have the ability to automate that process. So what I'm going to have Mihal do is he's going to go in there and he's actually going to go in and show you how easy it is to create a brand new workflow. And you can see the palette overall is incredibly simple. It's drag and drop. There's only a very few elements. It's very Visio-esque, and that's completely by design. You define an initial state, and then once you define that initial state, you can then specify what's in the form itself. So you can open up the form editor, and you can see it's very simple, very basic to use, and you can quickly and easily start adding the different initiation parameters as far as the design review is in regards to that form. And you can make it as simple or as sophisticated as you want that form to be, depending upon what your internal process looks like. So project is grayed out because that's automatically inherited from the Nexus server based off of the project that you initiate the review from. You can define the description as free text. You can define the review type, and then you can specify that as a combination pull down, and you specify the values of what those are. So in this case, Michael's going to say it's concept, schematic, schematic complete, schematic initial. Once again, it's very easy to build these and conform it to the way you work and how you review. So he can go ahead and save it, and then you'll see that the properties for that particular form on the right-hand side will expand. And then you can start adding additional states. Once again, you just drag it down. You can easily drag and drop and make a connection. There's not a lot of wizardry. There's no custom complex scripting. There's no, people that need to come in and do custom consulting for you in order to do the configuration itself. It's all drag and drop. Hopefully everyone can move the cursor. Okay? So you also want to start using intelligent names because obviously because the workflow diagram is available to everyone involved, it doesn't make sense to use names that people need to interpret. So you want to use simple and plain names so when people look at this, they know exactly where it is in the workflow and what's being done as part of that task state. So let's say Michael built this thing up, okay? And then he wants to add in some additional information. He spent the time to create all of this. He's going to give it a name and call it design review. He's actually built a quite sophisticated form as far as the initiation. And once again, these can be as simple or as sophisticated as you want them to be. You can see there are different information and that you have the ability to put in text labels to define what each one of those controls do. That way, the people who are doing it know exactly what those controls are for. There's no guessing to it. So you can see what each one of those fields are, and you can set a completion date, you can attach information, and so there are a number of different operations that you can do as part of that field, and you can go ahead and save it out. So I think you guys get the idea in regards to the ease of use it is to overall create the configuration itself, the ease of use it is to transition and do design collaboration as well as the process collaboration itself. So we also want to make you aware that there are some significant plans for Altium Nexus going forward, and we're working with a lot of different customers on this roadmap itself. So the first version of Nexus will be released later this year. So if you're currently on the Altium Vault and Altium Designer configuration, you'll be able to upgrade to Nexus later this year once it's available. And its initial version is really focused on Vault compatibility to ensure that you're getting the same functionality and you're not losing anything for what you do today, as well as being able to enable design teams to collaborate more effectively, not only through authoring, but also through process. Okay? And I'm not going to go through all of these items, but if anyone has any questions, you can come see me later. Thank you for your attention.